Welcome to our first lesson on Chapter 8. This is 8.1, Comparing and Interpreting Rates. Okay, so the very first thing we see is simply a definition. Ratio, which is a comparison of two quantities and can be written in three ways, as shown right there. One thing we should notice, we get the word rates from ratio. So rates is also, when we talk about rate, it's also comparison. To put this into perspective, it is something that we may understand. Think about a classroom. If we think about a classroom that has 10 girls and 15 boys, this is a ratio where we are comparing the number of girls to boys. If we put this in lowest terms, divide the top and bottom by 5, we see that we have 2 girls to 3 boys. Which gets us to our next definition, where it says a rate is a ratio of unlike quantities. Ratios and rates should always be expressed in lowest terms. So to what we just saw, the 2 girls to 3 boys, is in lowest terms. Example 1. We are given a situation that says here your pay is $60 for each 8 hours of work. What is your rate of pay? Well, what we do here is simply put 1 on top, your dollar value on the top, and we will divide it by the number of hours, which is 8. When we do that, what we find out is that for every 1 hour we get $7.50. So our rate of pay is $7.50 per hour. And there's more than one way to write this. Moving on. Our next definition is unit rate. A unit rate is a rate in which the denominator is equal to 1, and we just saw that. And when we talk about pay, $7.50 per hour, that is a unit rate because at the bottom the denominator is equal to 1. Okay, our first example we're given here is we're told about a Japanese-made car that can travel 50 kilometers on 4 liters of gas, and a Canadian-made car that can travel for 160 kilometers on 13 liters of gas. Which car gets the better gas mileage in kilometers per liter? And there's a little typo, I believe, in your notes, so fix this up right here. So let's first look at the Japanese car. What we can do is we take the distance, kilometers, divided by the amount of liters that we have, and what we find out is we get 12.5 kilometers per liter. We compare that, do the exact same thing with the Canadian car. We take 160 kilometers, we divide it by our 13 liters, we get 12.31 liters. But to answer this question, we must make a quick little statement, something like, therefore, the Japanese car has better gas mileage. And this is our last example on page 1. It says here, which is the better buy for a turkey? We're given two situations again, one where we have 12 kilograms for $42.89, and we have $1.49 per pound. We have different units for weight, so what we've got to do is turn these into the same weight. So this is not something you're expected to memorize, but you will be given a formula sheet on tests, and 1 kilogram is equal to 2.2 pounds. So how will we use this? What I would do is use what's called unit conversion, a conversion factor. A conversion factor is like this: 2.2 pounds over 1 kilogram. If we put two values that are exactly equal, it's the same as multiplying by 1, because if we have 2.2 pounds over top of 2.2 pounds, it is the same on the top and bottom, so it is the same as 1. But in this situation, we use different units. Why this works well is if we think about what we can, if we think about everything that's on the top as a top of a fraction, we have kilograms on the top, with kilograms on the bottom, we see that both of these cancel out, and what we have left over just on the top is pounds. So we just multiply 12 by 2.2, we get 26.4 pounds. So we have to then take that weight, 26.4 pounds, and put that underneath our $42.89 to get dollars per pound. We see $1.62 compared to $1.49 per pound. We say that $1.49 is a better buy. And that is our first lesson. On to page 2 in a little bit.